It's just a quick video then on the question ones that we had discussed, the 2014 and 2015. I'll do 2014 now. And then once I've shown you the method, I'll get you started on 2015 and ask you to take a look at it yourself first before I go into it, because you need to try these ones before you see them, because otherwise once you see them they seem a little bit too obvious, but when you're actually sitting on an exam they are challenging enough to get started on. So I'm looking at the 2014, I'm looking at question 1, I'm taking a look here, it's the water of crystallization. I'm going to focus in on the second paragraph. I'm not going to answer the questions down here because that's the old way they're asking for it. So I'm just going to work through the question the way I would normally work through it. We will get these answers, but we'll get those answers in a different format. So if we're taking a look, from what is over there, the first thing I pull out is the ratio, because that's going to be the most important thing I've got. So I've got 2 HCl's to every 1 sodium carbonate. And then I'm looking at a piece of information that gets me started in the question, and that's this piece here, 0.1 molar solution of hydrochloric acid, and we use 21.6 of it. So that means I would have had 0.1 molar if I'd had a litre, but I didn't have a litre. So I want to change that to the 21.6 centimetres cubed. To do that, I do the usual way. So to come down to 1, I divide by 1,000 and then multiply the answer by 21.6. So we're just using the fraction button, and it's 0.1 multiplied by 21.6, and I'm dividing it by 1,000. So that gives me an answer of 2.16 by 10 to the minus 3. So that means now that I had that amount of moles of HCl. That's what that tells me. Okay. So in the titration that I was doing, if I take a look at it and I take a look at my HCl and my sodium carbonate and I take a look at that ratio, if I had 2.16 by 10 to the minus 3, I'd half that amount of sodium carbonate. How do I know I'd half? Well, it's 2:1 ratio, so that's equal to 2 parts. So to find out what 1 part is equal to, you divide it by 2. So if I divide that by 2, I used 1.08 by 10 to the minus 3. So it's 1.08 by 10 to the minus 3 moles of sodium carbonate was used. Okay. And then we go back and we take a look again at the question and we see how much of that we were taking a look at. Well, that's the number of moles we had in the 25 centimetres cubed that we took, that were used, for example, in the pipette, which they explain in the question. So now I know I have a 1.08 molar by 10 to the minus 3 moles, and that's in 25 centimetres cubed. And I can do whatever I want with this now. So for example, the first question here in this one asks for the moles per litre. So I'm changing it to a litre. How do I do it? Well, the same way I did the one above. You look at coming down to 1. So again, it'll be 1.08 by 10 to the minus 3. It'll be divided by 25, and at this time it'll be multiplied by 1,000. So come down to the 1, divide by 25 and multiply by 1,000. So taking a look at that figure, I can divide it by the 25 in the order I've said, and then I can multiply it by 1,000, and I've got 0.0432. So I've got a 0.0432 molar solution of sodium carbonate. Okay. And that gets you in moles per litre. Then it asks you to convert that to grams per litre. So you look at what 1 mole of sodium carbonate is. So again, this part is very important that you show them, but I'm not going to show you because we've done this several times. So you're looking at 23 plus 23 plus 12 plus 16 plus 16 plus 16. Again, where am I getting that from? Periodic table. And that tells me 1 mole is equal to 106 grams. Didn't have a mole, only had 0.0432 moles. So that's 106, and you're multiplying by 0.0432. So in grams per litre then, 0.0432. In grams per litre, you had 4.5792. So you had 4.5792 grams in a litre. Okay. The second part of that question then asks you to work out the x. There's nothing new about that part of it. So that calculation is the calculation that we would have done. So once you've gotten to moles per litre and grams per litre, it's the same calculation. But for completion's sake, I'll show you again how to get the x value, or the percentage of water as crystallization. So they're going to ask for the 2. So if we take a look at the question, they said that they took 2.5 grams in 250 centimetres cubed. So you had 2.5 grams and you weighed that out into 250 50 centimetres cubed. In the last question then, you've worked out, in terms of what you have, you've worked out the number of grams, but you've worked it out per litre because it was grams per litre. So you have a couple of choices. You could take this number and you could change it to grams per a litre, or you could take the other number and change it to grams per 250. And your choice really, unless they ask it for in an unusual way. In this question, they say calculate the water of crystallization and the value of X, and they don't care how you choose to do it. Okay. If they wanted you to only use this figure, they would ask you to calculate the water of crystallization in the sample you took. So I'm going to assume that's the way they've done it, which means that if we take a look at the previous answer that we had, which was 4.5792, we'd put 4.5792 grams, and that was in a litre. We need to come down to 250. So the quick way of doing that is divide by 4. So we're dividing by 4, and we're going to get 1.1448. So I had 1.1448 grams in 250 centimetres cubed. Okay, but they weighed out 2.5. So the difference between these two numbers is the amount of water that you had, because this is the amount of sodium carbonate that you had. So it's 2.5 then minus the 1.1448 grams, and that will tell me how much water I had. And in this case, I had 1.3552 grams of water. To change that to a percentage then, it's that, so 1.3552, and you're divided by your 2.5, and you multiply it by 100 over 1. So if they asked you, for example, in the sample you had, other than that, you could do it the other way. To be honest, 90% of the time, more than 90%, probably 99% of the time, they're not going to dictate to you how to do it as long as you get the right percentage. So the percentage then is 54.208%. And when you look at the marking schemes, you will see that there's a whole load of options laid out. That's the option I've thought. But if you've grinds, etc., you might see different options. You might prefer a different way. It doesn't make any difference to you. The next part does. There's only one way to do the next part. And that's when you're trying to find the X out. Na2CO3 XH2O. Okay. You are now comparing sodium carbonate to water, and you're trying to create the ratio that you had in the first part. So in this very first part, you had a 2:1 ratio. Now you're trying to find out what that ratio is. Once you slip into ratio, you must be working in moles. So there are no choices here. It must be moles that you're working with. And it's up to you whether you work in moles per litre or moles per 250. And the reason I'm saying 250 is because this question has 250. So some questions will have 100, some questions will have 500, some questions will have 600. To be consistent, you must choose what moles you're working with. Sorry girls, I know there's a lot of noise, but someone's back in from playing. Okay, so if we take a look, we're going to take a look at sodium carbonate. So for sodium carbonate, I had 1.1448 grams in 250, and for water, I had 1.3552 grams. Okay, and they're both the numbers that we have above here in the 250. So I'm going to change them now from grams into moles. So 1 mole of this stuff is 106 grams, and 1 mole of water is 18 grams. Where did I get the 18 grams? 1 plus 1 plus 16 from the periodic table. Okay, so I didn't have 106 grams, so again it's 1 divided by 106 and multiplied by 1.1448, and that'll tell me how many moles of this I had. And it's going to be the same here, 1 divided by 18 multiplied by 1.3552 grams. And we're going to change them to moles. Okay, so the first one then is 1 by 1.1448 divided by 106 is equal to 0.018, so 0.0108, sorry, moles. And the next one then is 1 divided by 18, and that's multiplied by 1.3552, and that's 0.07528 moles. So now we both have them in moles. Now we have a ratio, but it doesn't look nice. So we're going to try and make it look nice by changing one of them to 1, because we'd normally have ratios 2:1, 3:1, 4:1, 5:1, and that's what we're going to do. So the first thing is to decide which number of these is the smallest. So this is the smallest number. So we divide both ratios by that number. Okay, and that's going to give me a 1 on this side. And then we're going to have our 0.07528, and that's divided by 0.0108. And that ratio is 6.9, so they'll round it to the nearest number. So that's 7. And then your x is equal to 7. And you must write that bit down, just because they ask you for the value of x, so you must tell them that you understand that that's the value of x. Or you could sub it back in up here. So you could write Na2CO3.7H2O to get the full set of marks, because there's always a 1 mark going for that slip if you made a mistake. So that's the new method with that old question. And I don't think it's particularly that much harder, but it just is a different way of thinking, and it's putting everything that you have back in the other one. Okay, so this is the 2015 paper. So this is taking a look at a sodium thiosulfate and an iodine reaction, and you're given standard iodine solutions and you're given the volumes, and our starting point will be down here. And actually the 2015 paper lays it out the new way, to be honest, the 2015. So I'm not sure if we've done this, but it's laid it out, even the question, in terms of the answer. But the first particle would be to start from here and to change this into moles per 500 and then moles per litre. Okay, and then work out how many you had in 25 centimetres cubed, like I did with the 21.6. So I worked it with 21.6 centimetres cubed because that's what they gave me. You'll be changing this into grams per moles per 500, and you can change it to moles per litre and then down to 25. That might make it a bit easier because you're used to doing it that way, and that would be the starting point. I'm going to leave that with you then, girls. I'm going to post this video now Wednesday morning for you. I'm going to ask you to try this one, the 2015, if you're interested in doing it. Not everybody's interested in getting this calculation, and I understand that. Some of you are happy to take your hit and just use V1M1N1. But if you want to try it and you want to give it a bash, try it. Post your attempts in the pictures. I'll see then roughly where you're going wrong. And I'll do a video on this one, and I'll do that for you Thursday evening and Friday morning, whenever I get a chance, whenever there's a little bit of peace in the house. And I'll post that before the end of the week for you. These videos are going up like on YouTube. If you can't access them, please let me know, girls. So if there's a problem, you need to let me know, because that's the only way I can see around the length of the videos. But if there is an issue, let me know, and I'll see if I can email them to you in some other way. Other than that, I hope you had a nice St. Patrick's Day, and I'll be talking to you tomorrow, Thursday and Friday. Talk to you then. Take care. Bye.